All right. Good evening, everyone. My name is Andre Siron, and my final presentation topic will be about the sparkler filter. So, the theory and introduction behind it. Sparkler filters have been used for polishing, clarification, and particle removal for a number of years. They were used as a common method to trap carbon fines used in upstream decolorization processes. So, they have a wide usage in both the pharmaceutical and chemical industries for filtering out foreign and unwanted elements from liquid. And how it works is liquid is detected with pumps through the cartridge's center channel from the bottom of the body. From there, the suspended particles get retained on the fitter medium resting on the filter plates, and the clear filtrate emerges from the plate side holes inside the tank and flows out from the bottom. So for parts, essentially this is a diagram showing specifically a horizontal plate filter, one of the many types of sparkler filters. And so, how the process works is the initial liquid is poured into the body feed tank, down through the tube into the body feed pump. Usually, there will be a switch, and once it is turned on, pressurized air or gas is released, pushing the liquid through and up the tube into the inlet. And once liquid is starting to flow and rise into the filter tank, the filter plates begin filtering out the unwanted and foreign substances. From there, the clean liquid is dispensed through the outlet as the pressurized air continues to push the now clean and filtered liquid through the tube and is stored in the pre-coat tank. Continuing on parts, most sparkler filters are either made out of stainless steel, titanium, copper, or iron. Filtration capacity, on average, it can filter anywhere between 500 and 1,000 liters an hour and can house anywhere between 10 and 20 plates. For design, most are fitted with a heat or a coolant jacket to decrease viscosity, drying, and other factors related to temperature control. For end cycle discharge, most models are either use air, nitrogen, or some form of pressurized gas, forcing the filtrate through the system, ensuring maximum batch filtration and economic return. For body feed, additional material is added either before or during filtration to counteract resistance created by the solids to be filtered. And here I will show a short little YouTube video just to give a better visualization. So for application, typically you will see a sparkler filter used in these major industries, which include the pharmaceutical, chemical, and food and beverage industry. And the purpose on why they use it remains relatively the same, and that is to filter out microsolids and impurities from liquid material during the manufacturing process of research and development of marketed products to ensure that they are safe to use and or consume. And these products can include, for the pharmaceutical industry, that would be antibiotics, antioxidants, cough syrups, detergents, dye, glyceride, glycerin, etc. The chemical industry, these include acetic acid, acetone, acrylic acid, activated carbon, acetylene, etc. And for the food and beverages, these include honey, sugar, salt, alcohol, milk, juice, etc. So strengths and limitations. So one of the pros of using a sparkler filter is that originally this method of choice for these applications were that they were relatively cheap to operate. Even to this day, they are still relatively inexpensive to operate and purchase. As if you search online, there are websites that still sell these sparkler filters for only a few hundreds of dollars. One con of using a sparkler filter would be the safety hazards, which, for example, would be potential exposure to hazardous products such as diatomaceous earth (DE) or carbon powder, which may be used in the filter operation. However, companies such as 3M and Suno Zeta Plus are working on ways such as creating new and improved filters to help decrease and possibly even prevent these exposures, as well as they highly emphasize proper ventilation and operator protection efforts must be made while operating the device. And so this concludes my presentation. Thank you for listening.